Hello and welcome to this session as part of the FOSDEM Foojay Dev Room. Title of this is How Your Java is Still Served Hot. And what we're going to talk about is the way that we can continue to develop Java as a platform in a way that adds more features to it as developers require them. My name's Simon Ritter. I'm the Deputy CTO at Agile. So what we need to do is to start with a little bit of history and look at how it is that we've got to where we are now. Now, Java is incredibly 27 years old this year, which actually makes me feel quite old because I joined Sun Microsystems in 1996, just after Java was released, and it wasn't even my first job. But it does mean that Java has been around for a long time, and Java is now a very mature platform. We can see by the number of users that we have involved in Java, we can see by the popularity of Java, which is still maintained. If you look at things like the TIOBE index or the RedMonk surveys, you'll always find that Java is in the top 3 programming languages to use. And that's been as a result of a number of different things. Obviously, things like the fact that the JVM is very powerful, allows you to have the write once, run anywhere approach to deployment, and the fact that you can compile other languages like Scala and Kotlin and so on into bytecodes makes the platform as a whole a lot more valuable. So it's not just about Java, the programming language. Now, if we look at how Java evolved, obviously, 27 years ago, Java was released as a new language, and it became very popular. One of the things that resulted in was a lot of people said, well, okay, it's controlled by Sun Microsystems. How about if we make it more open? How about if we make it into an international standard, something like ANSI, which we have for the C programming language, or something like ECMA, the European Computer Manufacturers Association. And Sun at the time didn't really want to go down that route, and they decided that rather than handing it over to an independent body, as you like, what they would do is they'd create their own community process for this, and this was called the Java Community Process, and this started in 1999. So we've now been doing this for 23 years, and the Java Community Process has led to the development of a lot of standards for different parts of Java. So if we look at Enterprise Java, all of the Java 2 Enterprise Edition specifications came through the Java Community Process. That's sort of since changed, and the standardization of Enterprise Java has now been handed over to the Eclipse Foundation, and we have Jakarta EE instead. But also other aspects of Java, things like Java Micro Edition when it was still a thing, and various other bits and pieces. There are still some other what are called JSRs, which provide different functionality as well. But the kind of core thing today is on Java SE. Now, it's important when we look at the JCP as a whole to understand how that works and the way that we provide the standards. And there's what we can describe as the golden triangle of the JCP. Now, the first part is the specification itself. If we look at Java SE as a good example of that, that consists really of 3 things. So there's the Java language specification that defines all of the syntax of the Java language you use to program. Then we've got the Java virtual machine specification that defines what the JVM must do, but doesn't specify how it does it. So it specifies what it's got to do, but not how, which is why we can have different implementations of it. And then there's the list of all the class libraries that are included in the core platform. So that makes up our specification. What we then have is a reference implementation for that specification. And for different standards, different specifications, that will be different pieces of software. And we'll come back to that in a moment. And then the third thing, very important part, is what's called the technology compatibility kit. And the idea here is providing a set of tests that you can use with the specification. And the way that these 3 things interact is that the specification obviously defines what it is the platform does. So the language, the virtual machine, and so on. And the reference implementation is a good way of showing that you can actually implement that specification. So there is a way of building what has been defined. There might be situations where you could define something that you couldn't actually implement, but by having a reference implementation, you can prove that specification can be built. If we look at the relationship between the specification and the TCK, then the TCK is a good way of looking at the specification and seeing, is it ambiguous? Because if you can define a set of tests for how the specification works, then you can show that there are no ambiguities about how things are defined and it must work in a particular way. And then the relationship between the TCK and the reference implementation is that we can use the TCK to show that the reference implementation actually conforms to the specification. So there's a sort of cyclic thing between all the different parts of our JCP JSRs. Now, the next thing that happened was that, again, with pressure from the community and Java users, what people wanted was not just an open specification, but they wanted it to be open source. And there were some, various attempts at making different implementations which were derived from completely open source. But in the end, Sun at the time decided that they would release their implementation of the JDK so that we had an open source project that people could use and people could build on. And that's how the OpenJDK came about. 2006, it was announced at the Java 1 conference, and initially the code that was contributed was for the hotspot JVM and for the Java compiler. Now that took some time to get to the point where we had almost all of the remaining code provided as open source. There was a lot of due diligence that needed to be done because many people had contributed code, people like IBM and various other organizations had contributed code to the JDK project that was being used by Sun. And so they wanted to make sure that they had the rights to release that code as open source. And as I say here, it's almost all of the code. It actually took until JDK 7 before you could build a complete JDK from open source without any what are called binary plugs. So there were still a couple of things back in 2007, some things to do with font management and font rendering and color management, things like that. But this was the idea, to make Java both an open standard and open source. And we have seen this being very successful. So what I've tried to do here is to represent as many of the significant contributors to the OpenJDK project as possible. I'm sure I've missed some, so I apologize if people think, oh, hang on, our organization contributes to this. But it's interesting, again, to look at the selection of people that are involved here. Obviously, Oracle heavily involved because they acquired Sun Microsystems. They took over, if you like, the stewardship of Java, and they are really the people who contribute the biggest team of engineers and work on many of the big features that go into advancing the Java platform. But there are lots of other people involved in this as well. There's people like ourselves at Azure, Red Hat, Bellsoft, Alibaba, Amazon. Apple is an interesting one because even though Apple no longer support Java directly on their platform, what they did was they contributed a lot of the code that they had in terms of how the Mac would use Java so that it could be integrated into OpenJDK and people could still build distributions that would work on top of the Mac. So that was a good situation there. And the one that I find quite amusing with this is the one down the bottom there, which is Microsoft. Microsoft has some history, shall we say, with Java, especially right at the very beginning, because Microsoft released their version of Java, which wasn't quite matching the standard, if you like, of Java. And there were some legal implications, and Sun sued Microsoft. And it's good to see that Microsoft have now kind of come full circle, and they are actually heavily involved in OpenJDK. They're providing builds that work on Windows. They're providing support for various things in terms of some of the new ARM processors and various areas like that. Now, one of the things we've seen more recently is the idea of making OpenJDK more agile. And part of that is to move away from using the JSRs and the JCP, which is quite a heavy, involved process, to add smaller things to the OpenJDK. And because the JDK is more than just the Java SE specification, it's about addressing all of the different aspects of the Java development kit. How this changed was that from JDK 8, we started to see what were called JDK enhancement proposals. The idea being that it was a smaller piece of work rather than something that would be a full JSR. If you wanted a JSR, it was going to be a very big thing like modularity in Java SE9. So this was about smaller pieces of work. And as I say, also covering things that aren't part of the Java SE specification, but are still part of the JDK. And the idea behind this was to give people a sort of clear roadmap of things that possibly were going to be included in Java covering the next 3 years. So if you look at the JEP 0, which lists all of the JEPs that are currently under consideration or have been implemented, you'll see a long list of ideas about new features that can be added to Java. Not all of them will make it in there. It is the idea of having ideas submitted. Anyone who has committer status in the OpenJDK project can submit an idea, but obviously it needs to be implemented. The people who make the decisions about the direction of Java architects like Brian Gertz and Mark Reinhold, then need to decide that yes, that is something that they would like to see in the platform, and then it can be included. What this has also led to is the idea of incubator modules. So now we have something that is defined itself by a JEP. So we've got JEP 11, and it's about things that we want to add to the Java platform, but not necessarily making them final straight away. And it applies to APIs and tools. So incubator modules, if we think about Java SE9, everything now is a module in Java from the class library perspective. And the idea behind this is to say to people, okay, here's what we think makes sense for this particular API or tool. You try it out, you give us feedback on that, and then if there are things that still need to be changed, we have the opportunity to do that before it becomes a final part of the standard. And that way, there's still that ability to address any concerns from the developer community. If people really didn't like the API that had been defined, then there is the possibility that it could be removed completely, but I don't think that's very likely. First example of that was in JDK 9, the support for HTTP2 was introduced, and that went through a couple of iterations. There weren't actually any changes, it was more just about people trying it out, making sure they were happy with it, and then it became final in JDK 11. We also have the idea of what are called preview features, and we've seen this very much since JDK 11, that all the language features that have been introduced since JDK 11 are now introduced as a preview rather than directly into the standard. It's really the same idea of the incubator modules, but applied to the language and the Java virtual machine as well. So if there are things that we want to add, we can provide them as part of the platform, but not a final thing. And then people can provide feedback. They can say whether they like something or not. And then if need be, there can be some changes made to that. I'll mention this a little bit later on when we talk about some of the new features since JDK 11 and where preview features have been very useful to allow us to make some changes. So again, the important thing here is that these are fully formed features. It's not about sort of doing development as the feature is being used. It's completed, it's ready to go, production ready. It's just that we want to solicit feedback to see if the actual feature itself needs any changes. Because these things are part of the Java language, we need to maintain the write once, run anywhere approach so that we keep our standard in the way that it should be. To do that, what you have to do is explicitly enable preview features. So you have to tell the compiler that you want to compile with preview features on, and you also have to tell it which release you want those features for. And when you run the application, you also have to explicitly turn on those preview features. You don't need to specify which version you're interested in because that's encoded into the class files, but you do need to tell the system that you want to use them so that it won't break the standard. Let's talk a bit about OpenJDK today and how things are a little bit different there. So one of the things that happened a few years ago was that Oracle decided that they wanted to not just make the idea of the features in Java more agile. They wanted to make the idea of how we release Java more agile. We see today, continuous integration, continuous deployment, so we can deploy things much, much more quickly than we used to. Why not apply the same thing to Java? And so if you ask Oracle, they will tell you that JDK 9 was the last major release of Java, meaning it was the last release that had multiple years of development behind it. What they did after JDK 9 was to switch to what we now know and in the form of the time-based release schedule, where we have 2 releases every year, one in March, one in September. And that has been working really, really well. It did require some changes to the way that the JCP worked and the way that JSRs could be developed. But we've seen over the last sort of 4 years, 9 releases of Java and lots of new features, which we'll talk about in a moment. So it's really, really impressive the way that we've managed to make that switch and make it work so seamlessly. The other thing that really this changes is rather than waiting for features to be ready before we make a release, we simply say whichever features are ready will include in that release. If a feature is not quite ready, rather than delaying that release, we'll delay the feature to another release later on. With only 6 months between releases, it doesn't really matter too much because you're not thinking, oh, if I don't get that feature in, I have to wait 2 or 3 years. No, only 6 months. Now, let's talk a little bit more about OpenJDK, because sometimes this confuses people, especially with the way that things have changed as well, that I'll talk about in a moment. OpenJDK is an open source project, and the key thing there is it is source code only. If you want to run your Java application or your JVM-based application, then you need a binary distribution of a JDK, typically OpenJDK. And what we've seen over the last few years is a real sort of much larger number of distributions of OpenJDK. And this is good because it means that users now have a bigger choice over which distribution they can use. As I say, we can see in the middle there, we've got OpenJDK, the project. It's open source. And again, we've already talked about this. We have lots of people who contribute code to that. So Oracle, the main contributor, we've got Azure, we've got Red Hat, we've got Amazon, Microsoft, and all those companies that I put on the slide earlier on. That feeds into an open source project, and then we have different versions of that available. And then the people who want to create distributions can take the source code, they can build it for whichever platform they want to support, and then they can make it available to people to use. And they can do that depending on how they want to do it, in terms of whether they provide support, whether they provide commercial support, whether they provide free builds, all those sorts of things. So essentially, people take the source code, they build it, maybe they make some enhancements to it in terms of bug fixes and so on, and then they provide a distribution. In the case of Oracle, you've got the Oracle JDK. In the case of Azure, we've got the Zulu builds of OpenJDK. We also have our Prime builds, which are based on OpenJDK, but replace some of the parts in there. Then you've got things like Temarin from Adoptium, which used to be the Adopt OpenJDK builds. That's been moved to the Eclipse Foundation. And you've also got builds like Corretto from Amazon. Lots of different distributions. I haven't mentioned all of them there. What this means is you have a bigger choice. And one of the other things that is significant about this is the fact that what we now have is the idea of long-term support releases. Why this happens is because with a 6-month release cycle, Oracle said that it wasn't going to be practical to provide extended support and extended updates for all of those releases. Rather than doing it that way, what they would do is use the same sort of approach that people like Ubuntu use and nominate certain releases to be long-term support ones and would have extended support. Now, the important thing about long-term support releases is that they only apply to binary distributions. They don't apply to the source code. Source code is the open source project. People can contribute to that for as long as they like, for as long as somebody wants to lead the project. But in terms of the distributions, those are the ones that will have long-term support. Good news is that everybody has agreed that they will follow the same pattern that Oracle uses. So we used to have a 3-year long-term support cadence. JDK 11 was the last one. JDK 7 is the current. 17 is the current one. And what they've now done is said we're going to switch to a 2-year release cadence for long-term support, meaning that the next one will be JDK 21. As I said, JDK 8 was classified as a long-term support release. JDK 11, JDK 17 are the current long-term support releases as well. And you have different choices of JDK, as I've already said. So depending on who you want to get your JDK from, then you can go to that provider and you can download it from them. Let's talk a bit about modern Java then. Where have we got to? Well, if we just have a quick review of some of the things that have been added from a language perspective since JDK 11. So we'll talk about differences between JDK 11 and JDK 17, long-term support releases, because a lot of people, I'm sure, will be considering a move to JDK 17 from either JDK 8 or JDK 11. What things can you take advantage of? Well, the first of those is switch expressions. And the idea here is that if we look at the syntax for the switch statement as we had before, it's a little bit clunky. There's potential for errors because if we forget to put a break statement in all of our case blocks, then the way that it's designed to work is to fall through to the next one. And that might not be what you want. So if you forget to put the break in, you get some unexpected behavior in your switch statement. The other problem that you can have there is if you forget, in this example, to assign a value to the number of letters, then you get, again, unexpected behavior, and it can be hard to find the bugs in your application code. So in JDK 12, we now have a new syntax. We have the idea of a switch expression. Expression is where we perform some actions and we generate a result, which we can assign to a variable. That means that now we only need to make one assignment, rather than in the previous example where we had an assignment for each case block. Now we make one assignment, and that eliminates that potential for error because we can get the compiler to check to make sure that there's always a value being returned from each of the case blocks for our switch expression. We also see that we've got simplified syntax. First very powerful feature here is the fact that rather than having each case on a separate line, we can use this incredibly powerful thing, a comma separated list, and put them all onto a single line. I find it hard to believe that it's taken us 27 years to get to the point where we have a comma separated list for the case statement. Then we borrowed some syntax from the lambda expressions. We use the arrow operator, and the right hand of the arrow operator is what we're going to return from the switch expression. And if need be, we can throw an exception. The idea here is it's much simpler code, much shorter code, but doesn't lose any of the readability. So that's the key thing. We're not losing any readability. JDK 13 introduced the idea of text blocks, not a huge feature, but very useful for certain situations. In the past, obviously, Java has had the idea of string literals, but if we wanted to have multiple line string literals, we needed to concatenate things or include special characters, and it was just harder than it really needed to be. Now, we borrowed some syntax from Python, and we use 3 double quotes rather than a single double quote to indicate the start of a text block, and then 3 double quotes to indicate the end of a text block. Anything between those 3 double quotes is going to be treated as text, and that includes new lines, special characters, and whatever. Obviously, if we print out the results of this, what we'll see is that we get everything left justified. That's important because we need the indentation for our tags. So we don't want to just strip out all of the leading spaces. So we're actually stripping out here incidental white space. The idea there is that you can format your code in a way that's easy to read, but not have to worry about, okay, well, then I'm going to get extra spaces in the text block that I don't want. So much simpler in that respect. JDK 14 introduced records. This is probably one of the more powerful things that we've had introduced between 11 and 17. And what we can see here is that if we take a very simple data class where we've got a point, we've got 2 values being stored in it, we've got 14 lines of code there simply to create a tuple. And that's a lot of boilerplate code. Why don't we make it simpler? And the answer to that is, well, yes, we can. Now we have records. And if we take the simple example here, create a point as a record, now we can do it in a single line. We say record, point, specify the things that we want to store in that point, double X and double Y. It is like a class. It doesn't have any body to the class, so we have empty braces there. The compiler will provide all of the boilerplate code that we would normally have there. But again, we understand what's going on. We don't lose any readability by eliminating all of that extra boilerplate code. JDK 14 also introduced the idea of pattern matching for instance of. This is something that we're seeing as a sort of recurring theme in terms of new features being added to Java from JDK 14. Pattern matching of things, in this case, of types. So what we're doing is eliminating some of the additional boilerplate code that we would have for the instance of operator. If we see in this code here, if we want to test that a reference we have is an instance of string, if we want to use that as a string, then the first thing we have to do is an assignment to an object of type string and do an explicit cast. Why do we have to do that? Well, now we don't, because we can simply say if object instance of string, specify a pattern variable s, and that will then be assigned as a string referencing obj if it is indeed a string. And that way, within the true branch of our if statement, we can use that. The scope of s is valid, so that's all fine. In the else branch, because it isn't a string, it doesn't get assigned to the pattern variable, so the scope of s is not valid and we can't use it. The compiler can check that for us, so it would be a compile time error rather than runtime error. JDK 15 introduced sealed classes so that we could specify which classes are allowed to subclass a particular class, and only those classes are allowed to do that. Introduced a couple of new keywords here. These are contextual keywords, so you don't have to worry about things like sealed or permits not being used as a variable name anymore. And we can say, take our class shape here, and we can say public sealed class shape. So we modify it with the sealed modifier, and then we can add a permits clause, which specifies that the three classes that can subclass shape are triangle, square, and pentagon. Somebody comes along and tries to subclass shape with a circle, the compiler will say, circle's not in the permits clause, so you can't do that. JDK 17 introduced more pattern matching. This time, rather than for instance of, it's pattern matching for switch. And what this allows us to do is to extend the things that we can switch on. Previously, it's been enumerations, it's been strings, and it's been integer values. Now what we can do is we can say switch on a reference and then test that against specific types. And if we have a specific type, we'll also get a pattern variable, and then we can reference that within the body of the case and do things with it. Null is a special case here, and we need to be able to test for that. There is no pattern variable because a null is a null is a null, so we don't need a variable for that. And then with the specific types like string or color, we have a pattern variable that we can reference on the right-hand side of the arrow operator. The primitives we can't test against because they're not types in the Java system, but an array of, in this case, ints is a type reference. So we can say if it's an array of ints, then we can reference that and we can call the length method, or we can test the length of that. Now with pattern matching on switch, it has to be complete, meaning that we have to deal with all possible types, which is why in the first example, we have a default statement. Don't have to have a default statement, but we have to make sure that we've dealt with every possible type that we could deal with. If we take our shape example from the earlier slides, if we test against triangle, square, pentagon, and shape, then we know we've covered every possible class or subclass involved there. So we don't need a default. Where next? Well, we got JDK 18, which is coming out in March. This, I would say, is one of the quieter releases of Java. There's only 9 JEPs included in there. There's no new language features. And several of the modules here are actually incubator modules, and they're just a revision of one that's been introduced previously. So we've got pattern matching for switch is an update to the preview feature there. Still a preview feature, the vector API, the foreign function and memory APIs, incubator modules, which have been made an incubator module again. And so at some point in the future, they will be final, but not in JDK 18. The only things really of note in JDK 18 is it's now UTF-8 encoding by default, and finalization has been deprecated. That's a pretty big one, actually. Deprecating it. If it'd been removed, that would be really big, but it's at least been deprecated. Other things, Project Amber continues to add small productivity-oriented Java language features, and we'll probably see, I don't know for certain, so don't quote me on this, but we'll probably see in JDK 19 further pattern matching, specifically around record patterns and array patterns. So we could do something like this, where we can do if O instance of point int x int y, and then we can reference that within the true branch of that if statement. So it extends the use of pattern matching further, and that'd be quite interesting to see when that comes in. Project Loom is a big project that's been going on for some time now, and it's about how to scale up applications that want to use, possibly millions of threads in an application. That won't scale if you map every thread in Java to a thread on the operating system level. So Loom is about having multiple Java threads mapped to a single operating system thread. Essentially, we're adding the idea of a continuation to Java, and then having a scheduler which uses the fork join pull scheduler within the JVM to handle the context switching between those Java threads onto the operating system level thread. Project Valhalla is another big project that's still ongoing. There's definitely progress being made, but I'm not thinking that we're going to see a lot of Project Valhalla. Probably not this year, maybe next year we'll see things. This is about adding value types to Java, so better use of storage, and also the ability to have primitives being used within collections rather than having to use the wrapper classes. So we could have effectively a list of int rather than a list of integer. I don't think the syntax is going to be quite like that, but you get the idea. Just to summarize then, to conclude, Java continues to evolve. The 6-month release cycle is working really well. I would expect to see, with JDK 18, JDK 19, JDK 20, and so on, many more features being added to the platform, and we'll continue to get lots of interesting things added. Java is not being stale at all. It's being fresh. Still very open. We still have the Java community process. Each version of Java has its own JSR for the Java SE specification. There are OpenJDK projects. We have lots of JDK enhancement proposals, as I talked about. So lots of contributions from outside of just Oracle. It is truly an open source project. Lots of choice involved in Java. So there are now, as I said, many more distributions of OpenJDK that you can choose from. My only marketing thing that I will say here is please choose Zulu from Azul. It is free, so you can download it for free from our website, or if you want commercial support, we'll provide that as well. And like I said, there's lots of ideas for how to move Java forward in the future. And with that, I'm going to say thank you very much, and we'll see if anybody has any questions. Thank you.